Okay, so this is a second example using the Freon 12, and in this example we're asked to find the mass of chlorine in 5.56 milligrams of Freon 12. There's a couple different ways to do this, and the first way we're going to demonstrate is using the percent mass. So from the last problem we know that this is the formula of Freon 12, and this is the molar mass, 123.913 grams per mole. And so if we need to figure out the percent mass of chlorine, that's always going to be, in any sample, percent mass of something is going to be equal to the mass of chlorine, in this case, because that's what we're looking for, divided by the total mass. So we can make our lives really easy for ourselves if we assume that we're trying to find the percent mass in 1 mole of this stuff. Right? Because then the total mass is just going to be the molar mass, 120.913 grams. And now we need to have the mass of 2 moles of chlorine atoms, right? Because 1 mole of Freon 12 is going to have 2 moles of chlorine in it. That's what this means. It's a mole ratio, right? So that will be 2 times 35.453 grams, right? Because each mole of chlorine weighs 35.453 grams. We know that from the periodic table. And so running that through our calculator, we find that it's going to be equal to 58.64% chlorine, okay? So now we can use that value to find the mass of chlorine in a specific sample, right? So the mass of chlorine, right? Now we're going to basically rearrange this equation again, is going to be equal to the percent mass of chlorine times the total mass. All we did was rearrange that equation, and so that's going to be equal to 0.5864, where we're representing this percentage as a decimal, and we're going to multiply that by 5.56 milligrams, okay? And so, plugging that in, basically you're just going to get 58% of 5.56, which is going to be equal to 3.26 milligrams. So that's our final answer to the right number of significant figures, right? And what we did was we used the percent mass. We used the molecular formula to figure out the percent by mass of chlorine in the Freon 12, and then we used that value to multiply the total mass of our sample here of 5.56 milligrams to figure out what fraction of it was coming from the chlorine. Another way to approach this problem is to use mole ratios. In the first example, the previous video, we calculated the number of moles. So the moles of Cl2F2 in 5.56 milligrams equals 4.598 times 10 to the minus 5 moles. And if you want to know how we got that number, you should go to the previous video before this, where we actually calculated it. But now, if we know how many moles we have in this sample, right, now we can simply use the fact that there are 2 moles of chlorine for every 1 mole. That's a mole ratio. We can multiply by that mole ratio to get the moles of chlorine, right? So basically, we're going to multiply this by 2 moles of chlorine for every mole of Cl2F2. Okay? So that's going to give us twice this, which is 9.196 times 10 to the minus 5 moles. Okay? So if that's the moles of chlorine that we have, and we want to know the mass of chlorine that we have, we can just use our equation, right? We know that molecular weight equals mass over moles. In this case, we want to know the mass. we're given the moles, and we can look up the molar mass of chlorine on the periodic table. So we can say that the mass of Cl is going to be equal to 9.196 times 10 to the minus 5 moles times 35.453 grams per mole. And multiplying this out, we will get 3.26 times 10 to the minus 3 grams. And 3.26 times 10 to the minus 3 grams times 1,000 milligrams per gram. Right, if we're just going to do our standard dimensional analysis to convert grams to milligrams, that's going to be equal to 3.26 milligrams. So we get exactly the same answer that we got the first way we did the problem, where we used percent mass. Okay? So either both of these are approaching the problem using the same given information. In one case, we think in terms of percent mass. In another case, we think in terms of mole ratios, but we arrive at the same answer